going to edit data of the Cave Nebula that we gathered in the previous streamings. So what I have done until now is I integrated the data and I spare you this waiting time, and I have used the linear fit. Where is the linear fit? The linear fit process, using as a reference image the oxygen. So a moment, I want to fix the audio. So what I will do now is I will combine those three channels and see what happens. So to start with, I will use I want to use some method that I found online, which basically using what is called dynamic narrowband. So I will use the pixel math process. Let me reset it, and now I will copy the expression and I will use different expression for different channels. So I have actually, okay, I'm copying right away this. So let's say the inverse of the oxygen, close brackets, power, inverse, open bracket of oxygen multiplied H alpha. I'm lost one moment. Oh, no. This is for the green channel. So it's oxygen H alpha. No, I was wrong, sorry. Let's correct immediately. This is like this, plus then the inverse of oxygen multiplied, no, power, the inverse of oxygen multiplied H alpha. So let me check again. Oxygen, power, inverse of oxygen, everything multiplied for sulfur, plus the inverse of oxygen, power, inverse of oxygen per H alpha. Okay, then we go to the green channel. It's double bracket oxygen per H alpha, power, inverse of open bracket oxygen multiplied H alpha, close, multiplied H alpha, plus inverse open bracket double bracket oxygen per H alpha, close brackets, power, inverse open brackets oxygen per multiplied H alpha, double brackets. Here I think I missed one. No, here I put the wrong one. Correct. Multiplied oxygen. And then the blue is easy. It's just oxygen. And that's it. So let's combine these three in a new image, which should be color space RGB. Let's go. Oh, sorry. I have to. I suppose there is an error here. Okay. It was easy to find. That was easy to find. And let's see. What do we have here? Okay. So it's basically looking as an HOO image, which is fine. We can work with this. Yeah, we will work with this. It's okay. Okay. And what I will do now is I will make a copy. I will quickly make the image non-linear with this simple script that I mean, it's very quick and I'm lazy, so I will do this, and then I will utilize immediately StarNet. With this StarNet, what I want to do is I want to create, well, let me check first something. I think the stars looks pretty okay. Then with this, what I want mainly is the star mask. I really find it hard to make a star mask each time with a different photo, which will need different parameters. So I just want to use this quick StarNet, not star mask, sorry, StarNet. So create star masks is selected and I will run it. It will take some time, but it is what it is. In the meantime, we can have some fun with the Astrowind.
My heart.
So 5%, it will take maybe 5 to 10 minutes, even with all those cores that I have. So let me open another window, and while this is working, we have some fun. Let's log in. Wow, the dragons. Bavara. I think this is the nebula I really want to image so bad, but I've checked from my location. It's really hard to get a good position for this, so I don't think I will have ever the chance to do it from here. I will have to do it in remote. It's really the correct name to use for this nebula. It's really easy to see the two dragons. Beautiful. Takahashi Toa 150. Wow. 20 hours total. This is in Deep Sky West. Nice. Super. Let's have a look at the Cave Nebula for some HOO inspiration. Big color, yeah. This looks very zoomed in. So let's put some filters, select awards, and let's select topics. Okay, so the majority is say big color. Oh well. So actually this is with a color camera, with a 10-inch Newtonian. I really want to see some narrow band. This is for sure RGB mono. RGB mono, let's see this one. Okay, so this is a narrow band. It's using Astron H alpha 3 nanometer. No, I think he used the color filter and then used the H alpha for luminosity. Then, nope. It's really nice, but ooh, this looks nice. This looks so nice. This is a mix. It's sort of HOO for this part, and then there is the oxygen. That's a really nice interpretation of this nebula. See this one? This is color camera. In the meantime, 68% on that StarNet. This is a starless version. No, it has the stars, mono, H alpha, and oxygen. Yes, here we are. Okay. Wow, that's a nice telescope. I mean, this detail, I don't think I have them. But I feel like some... here they are. So... okay. Let's try to get something like this. Let's try to get something like this. This is very zoomed in. We will have a chance to do a wider field, plus of course we can do also a crop. Let's see if we have some Cave Nebula that won the Image of the Day award. Image of the Day, search. Oh yes. So I think there are different oh. Wanted to image this region for a while. Took me some time due to the weather. Yeah. It's hard to make narrow band to pick up the reflection of the nebulosity, but he was happy about it, so yeah, I suppose you should be happy. Oh, here we are. We have done it. So I have the star mask now. I will just make it here on the side, and I have also, let's say, the starless version, but as you can see, there are some artifacts, so I will just put this here. I don't think I will use this. My plan of attack now is doing first some deconvolution. So first of all, I will run this script PSF image. With this script, I will be able to get, let's say, the shape of my stars in order to do the convolution. So let's start this on this image. Will take some minutes and we can go back here while we wait. Oh, so yeah, let's see some other image. I think these are all RGB. There is this SHO. This was in 2015. Wird schön, Mann. Gut gemacht. 2.8. F2.8. Wow. This is something fast. With a 0.73 correct. Oh, this was super fast. Marcel Drexler, the master. The master itself. Himself. Okay. I think those colors are a bit harder due to my skills. But is this color or is this RGB? Color count? No. Oh, it's actually HOO. So it's up to me to make something like this. Oh. Let's see. 66%. 70%. Wow, okay. So I will go back, but I keep this open, and then I will open again the one from before, because those two will be, let's say, my inspiration. Which one was it? Barry Wilson, I think. No, this is with RGB. Yannick, was that you? H alpha, green, no. This is a color, no? RGB. Okay, we have our PSF. I can close the process, so I will close the PSF here, and then what will happen? Okay, let's open the star mask. I want to extract just the luminance because I need the monochrome image, and let me change identifier star M. S for mask, which is not Elon Musk. Okay, then I open deconvolution, so PSF is correct name, and deringing. the star mask here, I have to search the correct one. Star M, the one that we just created. And these are the parameters that I usually use. What's the only thing that really is going to change is the global dark. I have to make tests for this, so what I will do now is create some preview. Wait. But first, so let me first put another mask. So okay, it has created a copy. I will make a quick, let's say, stretching so that the image is not linear. I will extract the luminance that I can use as a mask. And then what I will do, I can close this. Yes, I don't care. I put mask. Oh, I have to change name. L mask, which is also very similar to Elon Musk, but it's not. So what I will do is I will apply this mask. Where is it? L mask. Good. Control key K to hide it, and then I will focus on my image here. You know what? First of all, I see there is a lot of noise here. So what I will do is I will go back here and I will do some noise reduction first. These are my typical values. I use Denoising, which is very soft, and I will do it, let's say, more than once in case I need it, because I just want to go step by step. I don't want to go very strong. So I will invert my mask that I will target mainly the dark area. Control K to hide it, and I will just increase it a bit because I mean I don't really mind going a bit stronger on those dark areas. Well, let's be equal with every layer. So I have, let's say, 4 layers, and I will apply some noise reduction on each of them. And let's go. Let's see what happens. Should not take too long. And then we can zoom in and see the differences, if there is any. It's quite noisy, this HOO, huh? Mamma mia. Has something happened? Actually, yes. I will apply it again. I mean, let's make a comparison. You can see a lot of this greenish noise. You know what? I will just use another... I have an idea now to improve this noise. I want to see the noise in these images here. It's much better. But look at this. Much better. Okay, so let's go back again here. So it's much better. And what I want to use, just to see if there is some greenish cast that I can clearly see. Let's remove it. Did we remove it? Sort of. Yeah, I would say I can see the difference. And for me, in the linear phase, I will leave it like this. I will leave it like this. Yeah, I think so for the moment, yes. Then we will see if we need something more. So now I will show the mask and I will invert the mask. Looks everything red. I will hide the mask because it's hurting my eyes. And now let's go back to the convolution and we start doing our test. Clone preview. Let's make like this. And let's start trying these parameters. Should not be too slow. Okay. To see the difference, I will compare it with the yeah, I think I can see some improvement. Okay. First test with 002. Let's go 008. Let's see what happens. I want to do a series of quick iteration to quickly see, okay, is the results good or not? And as you can see here, it's not good with 0.008 because you have these dark rings around. So I will reset this and I will go maybe just slightly lower than before to see how much can I push it. Let me see. This is the first tentative. This is the second. You can see really a darkening. And this is the original. Oh wait. No, 15 is too much. I start seeing the dark rings, so for me it's no go. I think we really found a good spot there. I think this looks very good. Absolutely. It's really similar to the first iteration, but for sure it's slightly better. Yeah, I think this is I'm happy with this, and I will run it once. It will take some time, but we will get some more detail out of this linear phase. Should not take too long. Let's go check something else. Bubble Nebula, wow. The accidental astronomers. Hello, Bubble. Nice. Lol. This is the little man. Wow. Guess this is the Soul Nebula. Wizard, California. Okay, this is from the other hemisphere, that's why it was not so familiar to me. Wow. 12 panel mosaic. Okay, so the convolution happened, and actually I can see already the results are quite nice. Absolutely okay. I want to quick to see if I do it twice what will happen. I would say it's a no-go. There is some weird artifact here in the stars, which I don't like, and therefore I will just go for one cycle of the convolution. That's enough. It's already a good result. And now what I will do, let's think about it. I want to try to sharpen a bit the image. So now I inverted the mask, it's protecting the stars, and I will try to use some sharpening, which is basically similar to the denoising. Oh, that's too much. What is this? What is this abomination? Let's make it like this. One order of magnitude lower. Oh, I'm not sure I want this now. No, this I don't like. What I will do now, I will just delete all the previews. I will remove the mask. I will call this SHO base. I will copy an image just to as a sort of a checkpoint. So now I will go for screen transfer function. I will go for the process histogram transformation. I will reset both of them. I will go here and okay, forget about this. Why are you so big, my friend? Okay, so let's go. Let's see what happens. Nothing, because I didn't apply it correctly. Okay, so let's press the nuclear button. Oh, this looks very nice. Let's go here and okay, let's say now we are in the linear phase, in the non-linear phase, sorry. I want to check if something will happen if I do the SCNR again. Actually, it did, I think. Yes, it removed that cast of green, which is okay. I'm really starting liking it. So what I will do now is I created a copy. What I want to do now is I will extract Luminance mask. As it is now. I know that I did it before, but I want to do one with how it is now, and let's say mask L-com, Maskelcom, and soon you will know, you will understand why this name, because now what I will do first is convolution. I want to ruin this image. No, it's the wrong. Okay, I need to make this thing smaller because it doesn't fit my window, even though it's 4K. Okay. And I will focus here just to see. Something like this. So you can see the difference. I'm making the image uglier. Look, now it is like this. I want to make it like this. Why? Because it will help me managing the noise. That's too much, probably. Yeah, let's make it like this. Let's make it like this. Let's make a test like this, and let's see what we can get from it. So basically, I'm going to ruin the image. And I want to close this, but unfortunately okay, I can scroll. Okay, so convolution here is done. As you can see, it's much blurrier than before. What I will do is the following. I will now load the L-RGB combination, and I will select the Mascal comb, and I will go also for the Chrominance noise reduction, and let's see what happens. If the noise is better or worse than before. Oh. As you can see, I have very nice shorts because today I painted the living room. It's taking some time, but I hope we can get some nice results. Quite sure we will. Let's go. 98%. 99. The suspense is growing. Okay. So let's see. And to me, it looks much better. Here somehow I see a line. It's really a pity. But to me now the noise looks much better. Looks much better. There is still some bending, I would say. Let's start playing with the colors and stuff like this. Ooh. I will enhance a bit the contrast, not too much, but also going a bit darker. Say to please will help me a bit with that dark noise. Let's keep it like this. Should be okay. Let's reset. Let's resume here in the interesting part, and now I will go to HOO. Wow, some purple even. That's really weird. So where I like it the most? Oh, there is some purple coming in. I don't want that. Oh. I don't think I really need to change much here. I mean, I like the effect as it's coming out, but I want to really make it really soft. Really soft. Let's see, let's check. I think like this I like it. Yeah, it's slightly better. Let's go back here. Trying to get inspiration from this. You see, it's quite strong, the red. I don't have the same, but I mean, it's not easy to be like Marcel Drexler. Like this. Less. I like it, but less. Okay. I think there is this line. I will add it. Oh. Let's go back to you. For this, I want to try changing with this other color saturation. Am I going to see some effect here? No. No, honestly, I'm not getting anything better. Not getting any course transformation. I'm getting this purple I hate. This is horrible. This is actually horrible. Put back some music. Some relax music. No, I don't see any necessity to No, I don't like any additional change on this. Okay, let's do some more denoising. I think that more or less it's okay like this. Let's put mask, select mask. Let's put mask com. And I will invert my mask, okay. And I will do again noise reduction. I don't want to do any crazy editing post-processing for the HO. I want it to be quite easy. So you know what? I will try to do it again. I will use process convolution. Where are you? Convolution. Yeah, that's okay. And then I will use the RGB combination again. Really curious to see how will it improve. And where are you? Let's open it from here. Yeah, okay. that was not okay, in fact. Because I had the mask, which I don't want when I use convolution. It was looking too sharp to be convoluted. Then LRGB combination, and again I will use the Chrominance noise reduction. Let's see how it goes. It's too much. I will change approach. I have a few things that I want to try. Oh, mamma mia. I'm tired. This morning I woke up so early to start painting. And yesterday evening I went to bed so late to this month. The telescope rig after this quick 1 hour session. Yesterday we took some play at this blue filter, just 1 hour I think, nothing special. The fog came quite quickly. Okay, let's see if I see any difference. Honestly, it seems worse. So I will come back here and I will do again select mask, mask alcom. I will show it, I will invert it, I will hide it, and now to the noise reduction I will not attack the luminance but the chrominance, and it will be 0.16, always 0.16. Let's make a try. Okay, let's go. Let's see what happens to the chrominance. Layer 1, layer 2, layer 3, layer 4. Well, I cannot solve this line. I will make a crop and this will be exactly my line, I suppose. There is no other solution for the moment. Okay, let's see. I think it's working. I will make it another time just to check. Wow. 20-inch. $20-inch telescope. Total integration time 12,000 hours. How is this possible? How many telescopes does he have? Sorry, if I click here, what's that? So let's see if I'm really gaining anything here. Well, I actually think so. I actually think so. So let me show. And now I want to do, let's say I save this momentarily here. And then I will do sharpening. Let's do it here on the, say, lightest. Oh yes. Right. Yes, it's working. Well then, I will go back. I will invert. I will do another. One last round. Then I will have a, let's say, flat field view, just to be sure that I'm not missing the impact on the global picture. Let's see. Takes sometimes. Let's go here and let's see. Don't see any change with the flat field view, but I can see the change here. Absolutely, I can see them. And now what I will do is actually what I was doing before. I will sharpen. So let's invert. Let's go. Let's go. Let's go. Another round. let's go. Slowly, slowly. Okay, so what I want to do now is the following. Just want to see how is the contrast level. My god, it's so bad, this dark. Those dark spots are so bad. Let's remove the mask, and I want to use a script which will... No, first I want to use one last time I want to check the contrast and stuff like this. So curves transformation should do the job. Zoom the part where I really care, and RGB. I really like it more. Yeah, something like this can be absolutely can be. I will just lower a bit the saturation because too much blood. Just slightly, it doesn't have to look dull, but not even so flashy. Okay, so let's go for to script. I want to make something quicker, something quick. Dark structure enhance. Let's make the amount really low. Slow iteration. Okay. Let's see what happens. This should enhance the dark nebula around the mid. Ah, this noise there. I think in the end this kind of post-processing is not too complicated. It's quite easy. There are a lot of process and scripts that basically do all by themselves. Just need some quick and easy processing. Is it finished though? Oh yes, I guess. Oh yes, just this. I think just this area is very nice to enhance. Oops. Yeah, I think so. Okay, let's go again. Select mask. I want to do something more, some more sharpening. Let's see. It's okay, or am I going too deep? I think with this I went too deep. The star's edge looks nervous. Okay, this is better. I think it's like this is better. I think that's something honest, nothing special, nothing absurd. Probably later I will make a crop like something like this, just to get rid of that black noise. Mamma mia, it's so horrible here. I want to get rid of this noise. What's the problem here? I mean, if not, I will leave it like this for the moment. That's okay. We have a comment on YouTube, but I don't understand it. How is getting this? Well, these dark spots here. How do I? Oh, it's horrible. You know, now I did like this. I want to make just a quick check that this formula I used with pixel matte didn't mess up too much. And I will do something like this. Pixel math again. I mean, for this picture I think this editing is enough. I'm not able to solve this issue. I mean, not with my ability. But I want to see something. Maybe this channel combination that I did is not the best. So where is pixel math? Give me pixel math, orange selection. I'm not even able to remember the alphabet. I want to put this here. Now what I will do is let's do something different. I will make 0.8 where h alpha plus 0.2 where sulfur, then green. I will do something similar. 0.7, 0.3, and then I will have the HO, which is okay. Let's see if I have this noise, this horrible noise. Well, please show yourself. Channel combination. Okay. I mean, there is no such noise. Something I ate. Okay, well that's already much better. Pixel math, where are you, pixel math? And I will do like this. I will delete this. HAB, let's see. Just want to use some sulfur. It's a pity we have it there. Oh, well. There is basically no noise as it was before, so actually it makes sense to use the same exact method I used there, but to do it on this type of combination, because actually this is much more clear than, I mean, what is this? This was very fuzzy. No, I don't like this. I mean, I like how we did it, but it was ruined from the beginning. I was not able to understand why. But now, I really should use it on this one. It really looks much cleaner, much nicer. Look at the detail here. No, this is absolutely the way to go. And sorry, I just want to make another process SNCR. And I will just make some quick. Let me think. Okay, I will do in this way. I will do it this way. I will do it very quick. Now I know every single step that we did. I can remember it very well. The linear. It will be quick. And I think we can reach the final result to be much better than what we had before. This image is much cleaner. I really like it more. Okay, so let me extract the luminance from this. This image is much better. Good. Let me identify L. Very simple, very clear. Let me use mask L. Let me hide the mask. Let me use the convolution, and we use exactly those parameters because we know that they were working. The star mask will not change because basically the stars are always in the same position. This is why I usually don't do any dynamic crop from in the beginning, because I mean, if I do it and then I have to add some of the image I edited before, it starts to be problematic, so I just do it in the end. I know that there is some process which can have an impact on this, but for the processing I do, this is not really important. I absolutely despise this dynamic narrowband combination. I mean, it was just not suitable for my image. And gave as an output something that was very noisy. That was a pity. So now we will do quickly this. We try to see if this big color image can be much better than what we had before, and then we will try it also on the SHO typical Hubble palette. I actually want to see what are the values for the Hubble palette, the classic ones, without any weird dynamic. Okay, I have the formula and I will use it shortly after this. And yeah, we should get a very nice image now. Okay. Ooh, a bit too strong. It's a bit too strong. Yeah. So let's make it like this. Let's make a quick preview and let's go up with the numbers here. Should be that's already too much. 4. I don't want those dark rings around the... Why? Let's make it like this. Now this will be for sure an horror. Means I need to go lower. This is always trial and error. This is always trial and error. It's okay. Nope. Maybe in between. Nope. I want to try this. From the easy processing suite. Easy decom. Star mask. Well, this easy decom is not too easy now. It's horrible. So I think there is a problem with the star mask. So actually I will redo it. So let's put this in standby. Let's remove the mask. Let's make a copy. Let's linearize it. Let's delinearize it. Whew. Not so easy. Shortcuts don't work. And let's do StarNet. What's the problem? Oh God. How is this possible? I don't understand. I really don't understand. Dark flat. Let's delete this and move it here. It's unbelievable the space that PixInsight uses with this camera. We need to free some space. I don't understand why he's using. Maybe it's for the swap folders, I suppose. Whoa. Nice. Nice colors. Monkey Head Nebula is really clean. So I will finish it 82%. To 94. Please give me my giga. I don't know. What is Cave Nebula? Cave Nebula is the name of this, let's say, combination of different gases. This is sulfur, hydrogen, and oxygen. Those gases are in the space, in the universe, and we are able to see those gases, and they appear like this using some astrophotography gear, some astrophotography camera. The name is given usually by the person who discovered it, and sometimes it's really easy to understand, sometimes it's quite hard to understand. If you want to know my interpretation to why Cave Nebula, I see, let's say, this structure here to me looks like the entrance inside a cavern. So this is really my interpretation, but I mean, it's not, I'm not sure that I am correct, it's just my interpretation. And I know from other pictures that this is called Cave Nebula. But yeah, in this case, it's not so clear why. I showed this to my girlfriend the other day, and she said, this looks like a cat. And I still cannot see the cat here. I don't know if someone can see a cat here, but I don't. I hope this answers your question, Ganoria. So the Cave Nebula is just a photo taken at some point in the past of those gases, right? Are those gases still there like that, or the form changed? Yes, you are correct. Basically, this nebula is, I don't know actually how many light years from us, but basically we are seeing it as it was in the past. For sure now there is some change. I'm not sure in this kind of nebula if the change that we can expect are of what, let's say, what magnitude we can expect. That I actually don't know. Let's try to see how far away is the Cave Nebula. Cave Nebula, light years. 2,400 light years. Wow. Yeah, so basically we are seeing it as it was 2,400 years ago. That's quite a lot. I mean, maybe it was the period of what? The Egyptian, the ancient Egypt called. Let's say the, how to say the, oh, so we are seeing it as the ancient Egyptian could have seen it if they had a teleport. Ah. So I was checking that I failed. Let's do like this. I have to empty some space. Every time we take picture of nebulas or object in the sky, basically we are photographing the past. The further away they are, the more in the past we are seeing actually. But I really have no idea what kind of changes I could expect after 2,400 years. Unfortunately, my expertise is not so deep in the, let's say, astronomy, cosmos. Yeah. We have nice sensor able to reach to, let's say, capture those photons that are traveling. Light is traveling at light speed and still it takes so long. I think that with naked eye the only real object that I was able to see with my eyes was Andromeda. It should be the closest galaxy to our galaxy. If you think about how many years in the past you are seeing and how far this thing is, you realize we are quite small people. While I wait that I say empty my hard disk, I want to see what can I do with the colors. Oh no, greenish cast I don't like. Want to go to the reddish. Oh, doesn't look too weird. Once we can resume, we will give it a try. Do you do any astrophotography, Ganoria? Some Milky Way shots, maybe? Do you live in a dark place, or do you live in a city where it's quite, let's say, the sky is quite light polluted? Okay. Yeah, from the city, I mean, with the telescope still you can capture quite nice images, but I mean, just trying to see naked eye, or even with the telescope, just pure viewing, it's really hard. Countryside is the best place for doing such things. Okay, let's see. Okay, I have 40 giga free now. Yeah, if you go in the countryside and it's really dark, maybe there is no moon, I mean, the view is amazing. I was about 2 months ago in Italy, near the village of my grandparents, and it was really on the top of a hill, 700-meter altitude, countryside. You could see everything. Okay, let's start this StarNet. StarNet, let's go. Here in Switzerland, the light pollution is not so bad, actually. I went sometime to take Milky Way shots, and you really can see beautiful nightscapes. The whole Milky Way is really, really nice. You see if I can find some picture of those Milky Ways. Let's see. So what is the purpose of this? What can you learn from this phenomena? Well, me personally, this is just an hobby. I like photography in general, and with Corona, there was no chance to travel and to take pictures, so I said, what's the best, let's say, alternative I have for let's say, in-house photography? And I decided to try some astrophotography with the influence of one of my colleagues that was already into it. So on the picture, this was I think the year before Corona, and it was around 3 in the morning. It's near sort of village, small city. It's just an hobby, it's just photography for me. I'm actually not learning too much. I'm most interested in the artistic part, if I can say that. Not that I'm an artist, but I like to take picture. See if I have something else. Let me try here with Google Drive. For sure I have something there. Anyway, this process is taking some minutes, so we have time. So, oops. So this is also in Switzerland. This is it's a mountain called Sentis. And let's say, for someone who is in Switzerland, it's a popular place to go, so I added something else. This was also on the way to go, let's say, below this area, below the Santis. It was just pure darkness and stars. This is a similar picture. That's let's say the opposite way. So this is, let's say, the beginning of the Milky Way, and the one before was the end. So it's pointing completely to the other side. And I'm not sure I have something else. I have to find it. It's a long process. In this period, unluckily, the weather is not so nice, so I will have a lot of time to edit the picture I took. I have at least 6 or 7 different nebulas, so say something similar but different subjects, or different shapes, different form, different colors. And I plan during this period of bad weather plus Christmas holidays to work on those images and have some finalized picture. %85%. to make, let's say, a picture like this, you have to make multiple exposure of several minutes. So overall, I think for this picture I gathered a total of 14 hours. 14 hours. I usually take 5 minutes exposures, so then I stack them together and I take different images with different filters to separate, let's say, each one of those gases that are, let's say, in the space. Okay, so the process here is done. As you can see, I obtained a starless version, but what I need now is actually the star mask. So as you can see, I separated star from the nebula. I will just make this black and white, and I will rename this black and white star. I will just call it star. Then this one I can reduce it, I don't need for now. I will just put it on the side. Exposure is like a video. Yeah, basically it is in a sense that when you take a picture, usually you think about something instantaneous, even though it's not really instantaneous, it's just a few milliseconds usually. So when I say exposure, it's just, let's say, the length, the amount of time where the sensor is actually active to catch whatever photon is entering. If you think about long exposure, I think this is more common term for general photography. Yeah, so maybe with the long exposure you do a few seconds, 3, 4, 5 seconds. In astrophotography you usually do, I mean, you can do, there are different techniques. You can do a few seconds also exposure and you make a lot of them and then you stack them together, or you do less, longer exposure. The real limitation, there are different reasons to go for one way or the other. It really depends on your condition, where are you, let's say, with light pollution, and what kind of gear you have. Some of it can be suitable for very long exposure. I know there are people that do 50 minutes of exposure. I usually do 5 because after 5 I start getting, let's say, blurred image because it's moving a bit. My gear is not, let's say, super good, so 5 minutes is a bit of a limitation. So, okay. Okay, then what I will do here is the following. Select the mask, L, hide the mask, the convolution, I will call this star because we call the file star. We'll start with this value here and let's see what happens. So when we do this post-processing of the image, we do, say, several actions to try to get most of the detail out of it, to adjust the color, because as you can see now it looks all yellowish, but in reality, the color is reddish, let's say. So that's why I was trying to go towards the red before, but I mean, there are several ways to make it with the various colors, because like the telescope Hubble makes a picture with certain colors which are called Hubble colors. So I will later also try to do something like this with that kind of color. So let's see if I can manage now. I want to do something nice with this process. I want to extract some more detail. I think this time it worked correctly. So let me check the difference. Can I see the difference? Yes, I can. I can see the difference. So I'm pulling out more detail, which is nice. The stars are slightly stronger, but this is okay. So I think I will go on with this process and I will implement in the whole image. This is, let's say, when I say a process, is, let's say, an algorithm, a script that basically will do something, and this process, this algorithm in particular, is let's say sharpening a bit the image that was worsened a bit because of the viewing condition, not optimal really. So it's getting some more detail, let's say, that is removing some fuzziness from the picture, from the original picture. It's a quite powerful script. It can be easily overdone, but I try to be, say, cautious and not push it too much. As you can see, there are some border, let's say, on the top, on the bottom, that are red, are completely different color. This is because not all the pictures were taken exactly in the same way, so there is some, let's say, rotation of the equipment, and this will lead to this kind of misalignment. It's almost done. Last iteration. Okay, let's have a quick check. I really like the result. Absolutely yes. I'm not sure you can see it from the quality of the streaming, but let's say this is the before, and you have to see around the edges mainly, and it's a bit enhanced, and yeah, exactly. The red lines are, since you have to take multiple exposures, this means you will take many pictures. Let's say I took 14 hours, so probably I took, I don't know, 150 or something like this, separate pictures. Then you will have to align them, and between them there can be some slight difference, I don't know, due to the wind, due to some technique that recommend to have some sort of misalignment between the picture. And when you stack them, let's say you will have, let's say, this sort of strange colored borders, which anyway can be later cropped, and you will get, let's say, the nice framing, the best framing. So I'm done with this deconvolution. I will just do some denoising, so I will try to remove some noise from the picture. I want to invert the mask. I will hide the mask, and I will use some noise reduction. Let's see if I can get something nice. Usually we take as many, let's say, exposure as possible, because the more you have, the more detail you will be able to catch and the less noise you will have. So if you see, there are, let's say, some pixels inside the same area which show slightly different darkness, slightly different colors. This is mainly some noise, so in the post-processing I try to make it look as smooth as possible. I will try to zoom now to show the difference with one iteration. So as you can see, there is some noise. You see the color is not very homogeneous. It's really a subtle effect. I will push it a bit more. So I go here. This is the process for denoising. Well, this is a process that you can use for many things, but as it is set up now, this is for the noise. So this is the amount, let's say, is the strength that I'm using, so I will increase it a bit. Just to have a stronger effect. And I will reapply the process to the picture. In the end, I think you joined after I started. So let's say I'm trying to target something that looks like this. This is done by a very experienced astrophotographer, Marcel Drexler. And let's say this is a picture taken with very similar condition as mine, so I want to try to reproduce something like this. It will not be easy because his skill is for sure much better than mine, but yeah, okay, it's getting better. I will do it once again. And then I will switch to the next phase. I have to try to switch my color to one popularity, 5 viewers. Wow. No, thank you. There are quite few spammers online now. It's okay. 5 viewers. Okay, then I will remove my mask and I will move to the next phase. Histogram transformation. Okay, so let's see. Okay, now it's even a greenish cast. Okay, let's see what we can do. Pulse transformation reset. Let's see the preview. Let's go to the hue, change, go lower. Let's do something like this. Let's apply it. It's not looking so good. No, I don't like it. Let me try this other way. Before I was coloring also all the shadow. It was not nice. Let's do like this. I'm not super happy about the color, but for the moment it's not too bad either. So I'm playing a bit also with the contrast. I don't want it to push too much. Just want to just a bit. Then I see some green around the star actually. Am I correct? Some greenish yellow. But okay, let's say that for the moment we are in this condition, which of course is not so red as the target, but it's not, I mean, it's not too bad either. And let me think. Okay, now I will do this. I will extract luminosity as it is now. So means I will extract a mask, sort of, let's say, white where is light and black where is dark. Monochrome, so I will change the name as LL. Just for speed it up, I will make convolution process. Let's see the preview. And now I'm making the picture a bit fuzzy. I want to reduce, let's say, the noise, even if it means to lose detail. I will recover the detail shortly after. So I do like this. And then I will do the LRGB combination. And I will add only the file LL that we just created, plus I will add this noise reduction. Let's see. I really like this picture like it is now. It's quite this is actually the so-called natural color. I'm taking picture with a monochrome camera, which means it's a sensor that takes black and white picture. I use different filters, so then I combine them, and each of the three filters is going to one of the three channels, red, green and blue, so that in the end I will have a colored picture. But let's say that you have a normal camera that will take colored picture. If you're actually pointing to this target, you will get a color that is really very close to something like this. It's basically like this. I mean, in the end, if you see here, actually, you see, this is a very famous astrophotographer, Astro Backyard. If you see, he's taking the picture, I think, with the color camera, and this is what he's getting. It's probably nicer, but the color are very similar. The contrast, this can be, let's say, changed now, but as you can see, the color here is quite natural, and let's say it's really close to what the natural real color is. Okay, I think that the noise is getting even better. Yes, you can see here how we were before. A lot of noise. And now there is noise, but at least the color is more homogeneous. What I want to do now is increase a bit the sharpness. So I will select LL, correct, and I will go to Sharpen. This is basically the same process as the one I used for noise reduction. It's just that changing the parameter, you see noise reduction is deselected. Changing the parameters here will give different results. And actually the process is doing something a different processing on the image. Okay, let's see, the difference is actually not so bad. So I can push a bit more. Oh yes, it's popping. The detail here in the light part, it's actually coming out pretty nicely. Oh yes, I will go even more. Well, have a good night, and thank you for making some really interesting questions. I hope that you enjoyed. Have a good night. Okay, now maybe this is a bit too much. Those stars are starting getting too strong, but you know what I will do? I will do something different even. I will do the following. So, okay, until this one, it's okay. What I will do now is I will combine two images into one. I take the LL and the stars, and let's see what I can pull. So let's go to pixel math. Where are you, pixel math? There you are. Let's reset it and let's create a new image, and we do it in this way. LL, the image on the left, and we will subtract the star. Let's see what happened. So now, as you can see, we have mostly a starless image, but I want, let's say, darkest spot in the star, so they're really, I'm not doing any modification when I will apply the mask. So what I will do is I open again pixel math. I don't know why it's closed, and I will multiply the star mask 2 times. Oh, there we go. As you can see now, there are black spots where the stars are, so those should not be touched, I suppose. Well, I suppose I can go even stronger. Pixel math, let's do 3 per. Wow. Okay, so I will call this image mix. There is no real logic behind the name in this case, just... And I will then select the mask to be mix. And actually I should be protecting the stars. However, let me see, I don't think I'm really protecting the stars. But let's see. So 1, 2, well, until now, yes. 3, the stars looks still okay. And I think now the stars look not so okay. I think like this is the limit I can go. What I will do now... Let's think about it. We'll change again mask. We'll select LL. Let me check. And I want to use denoise just a bit. This picture, I see only one problem that I'm not solving right now. There is some green cast on the star. I will try to correct later, maybe in Photoshop. Should not be so hard. Okay. That's absolutely okay. Now I want to remove the mask. Let's go back to Bruce transformation. Just darken it to see what's happening here. It's creating some strange artifacts. Okay. Image 26. Whoa, no. Okay, let's see before and after. Yeah, I like this, I like it. Slight differences, nothing special. It's quite okay. Let me see the hue, if I can make it even more red. Yes, no. Guess that's a hard no. No. I don't want to burn it too much. Is it better or worse? I think it's worse. Oh, now we talk. Now we don't talk. Oh. Yeah, now it's not bad. Some saturation, not maybe just a bit less. Just slightly more. Very minimal. Or maybe a bit more. Okay. Let's see. Yeah, I think like this is okay. No. These weird things, no. Okay, like this. And now, what else we might have? I think it's quite well balanced. Maybe like this. Yeah, I think like this is better. We need to add some blue. Not too much. Okay. I think this is more neutral. Oh, this I want to delete. No, it's okay like this. Okay, now let's go to one of our last steps. This nice script, what is it? Dark structure remains. So just low, not too much. Should be okay like this. Is it done? I think so. Oh yes. Some really nice enhancement of this dark nebulas here. Truly nice. Well, let me see if I can do something better in this small area there. Mask. Okay, let's go again to curves transformation. Let's reset it. No. No. No, I don't like it. Okay. Okay, okay. I want to make a test. Quick test. Save as. Cave Nebula. HOO. Let's save a JPEG. I just want to do something quick. %, please. No, ECC profile, thank you. It's okay. And let's hope Photoshop. So open HOO, where are you? Yes, here. Okay. Let's see if I can make something better with Photoshop. Okay, first of all, hue and saturation. Let's see. Well, let's go to our classical color. I like that 0 I was set up. Well, not bad, like this. Oh, sorry, I want to go 0 and 0. And then I want to add to work only on the reds. Oh, wait. Oh, that's too nuclear. Oh, but something like this. Let's go to 0 here. And let's go to greens. Damn greens. You see those greens? They're hiding. Oh, the music. We need to put some more music. Okay, so greens. I want to change the U. Oh yeah. That blue is what I wanted. Now the stars are not greenish. Sort of more natural. Let me see if I have some weird colors. I don't think so. Let's go back there. Hue and saturation, reds. Well, actually, isn't it good? It's actually good. Yeah, I will go for it. Then let's see magenta. Do we have magenta? Yeah. Oh yes, we have. Okay. Those are the magentas. I actually like the give some more purplish color. Zero. Let's not go crazy. Yellow. I don't see any yellow. No, I did a mistake. Reddish, I really. I think this is okay, and the magenta we go. I think like this is okay. There is some. It's okay like this. I want to show that nebulosity all around, so I like it. Oh. No, this I don't want to change it too much. But this I like, to be honest. Not too bad. Let me see detail. That's not good. I think like this calibration I think that's okay. I think that's okay. Then let me do some cropping. And then that's it. Where is the cropping? I lost the cropping. But let's save it and I will open it again on PixInsight. No problem. Where are you? Okay, open. Cave Nebula. HOO. I think it's slightly better. It's okay. Then we go dynamic crop. And there we go. Our beautiful, well, beautiful, it's subjective, but anyway. Our Cave Nebula. Voilà. Les jeux sont faits. Mamma mia, I don't like this part here. Ah, it's washed. I don't like it. Close it. I take this one. Sharpness. Oopsie. Oof. Image process, dynamic range, dynamic crop, sorry. Let's go for it. Slightly tilting. See a bit more. And yeah, a bit more here. Here a bit lower. And we can go more here. Let's go. Cool. So I suppose that for the HOO, that's it. I don't like what I did in the some more, let's say, some more of transformation. Saturation. Really want to go here and don't want to burn. Like this maybe. Oh, what is this? Like this, there is more difference. This I don't like. No, I leave it like this. I'm doing too much casino, too much trouble, too much damage. 100%. That's it. Let's visualize it. Yep. Cave Nebula. Where are you? You're not opening. I think it's not too bad. That's not too bad. And then let me do an additional crop. Just dynamic crop. Let's see how it looks like. It's a bit too static. Let's see like this. I think I will save it like this. SHO crop. Okay. And then we have space on the hard drives. Yes. Okay, so that's decent, and I think that for tonight that's gonna be it. Oh wait, I forgot. I have to change the green. The greens I have to change. Let's open them. It'll be easy. It'll be easy. Let's focus on those stars here. Image, adjustment, hue, green. Bluish is better. Yep, like this. That's it. Save. Then I open the crop. And also here, image adjustment, hue. greens, and now they are blue. And now they are saved. Quality is top. Let's close it and let's open it again to check. Now that's correct. Yep.